Alright guys, today we're doing internal forces. Before I start, I just want to make sure you guys know what like internal forces are. Well, there's three internal forces. One is normal force, which is either like it's like an inside force on the object, by the way. It's like what the object experiences internally. So one is normal force, which is either like that, or it could be like that, based on how the object's experiencing. So like the object up top, how it has a compression on it. If that object has a compression right here, and then this is the beam, and we cut the beam in half, it's also gonna have a compression on the other side, but that's gonna be your normal force, because that's gonna be inside the beam. And it's kind of like, it's either like pulling or pushing an object. That would be normal force. The other one is shear. And shear, it's kind of like tearing it. So think of it like tearing it like that or tearing it like that. It's gonna go up and down only. So like the object I drew before I broke it up, it goes like this, it goes down. So remember, internal forces are always in equilibrium. So you can also use these formulas right there. So for our case, since we have a down force, we know our internal shear is going to be going up to balance that force out because we're doing equilibrium only. And our last internal force is our moment. And our moment is actually based on shear. Moment is like based on how far x along and your shear. Oh, that was a horrible explanation. Hold on. All right. So your internal moment also is going to have the same calculation as your moment, like your regular moment. So you have a 20-pound load on this beam that's going to force this beam to go clockwise, right? So if this beam is going to go clockwise, that means our internal moment has to oppose that and go counterclockwise because they're in equilibrium, so they're going to be the opposite of each other. So think of like your internal moment kind of like as the opposite of your external forces on the beam. So hold on, I'm gonna go erase this and I'm gonna show you guys an example. Alright. So I just made a random example on top of my head. It's a 10-meter beam. Both sides on the beam, right side and left side, are 5 meters long. And I'm gonna show you guys a little trick. We're trying to find the internal moment at x equals 5 meters. So to be honest, when you're doing internal forces, it doesn't matter if you start at this side or if you start at the left side. The internal moment at x equals 5 is just going to be the same. And all the internal forces are going to be like the same. So what I'm going to do is, I'm going to take, this is A, B. I'm going to find my roller, because remember free body diagram first, and I'm just going to solve for the roller first. So to solve for the roller, I'm going to do moment of A. Actually, I'll be right back. I'm going to just solve it. Alright, I'm back. I solved for my supports at A and at the roller at B. If you guys notice, there's actually no X forces on this beam. So since there's no X forces, you can just automatically assume that your normal force for this beam is 0. Now, here's the new stuff that you guys just learned this week. I'm just gonna cancel this out, scribble it out, because our n is 0. So now we have our V. And to find our V, internal forces, we're gonna use the normal equilibrium formulas we've been using the whole year. So for this case, I'm gonna just, V is a Y force. Say 0, because it's trying to shear the beam like that. It's kind of like cutting it. So I'm gonna solve for V right now. So I assume V is up because our A force is smaller than the downward force, 50. So negative 50 plus 37.5 plus V equals 0. So when you put that in the calculator, la-di-da-di-da, V equals 12.5 newtons. And that's one of our forces we found, one of the internal forces. Now that we found our internal force V, we just have to solve for the moments. And to solve for the moment, well, I'm not sure if you guys learned that yet, so we're gonna do that for another example. I just wanted to solve for the V in the end. All right. And this is just the last part of the first internal force video. If you guys didn't understand my little analogy. Here, perfect. So shear is kind of like, you know, you're ripping it. While normal force is like pulling or, you know, pushing inside like that. And I kind of drew little diagrams for you guys to understand that, and you can pay attention to that and the other professors' YouTube videos. All right, that's it.